Yesterday I was out with my camera, my Nikon P900, and I took some pictures of a lighthouse 17.3 kilometers away across the fjord. So I'm standing here outside the city of Horten in a recreational area, and I'm looking northeast towards a lighthouse here in Filtvet across the Oslo fjord. The distance is 17.3 kilometers. And here are my observations. So the first picture is taken from the car park, which according to Google Earth is 5 meters above sea level. So I'm holding my camera and I'm standing then 6.7 meters above sea level, and I get this picture here. And to the right you see what the picture of the Filtvet fjord, Filtvet lighthouse. So you see that it is, it is the only lighthouse in this area, and you see its very characteristics with this chimney in two parts here. You have the white house with two windows, you have the fence going here, you have a little shed, and you have the lighthouse right next to the house. Then I took a picture when I was standing at the sea level, so it's 1.7 meters above the sea level. So I got this picture here, and I sat down on a stone, so I was 1 meter above sea level, and I took this sort of blurry picture here. So these are my observations. According to the Earth curvature calculator, at an eye height of 1.7 meter and a distance of 17.3 meter, 12.5 meters at the target should be hidden. So I should not be able to see anything that is less than 12.5 meters above sea level, 17.3 meters away. And this is because of the Earth's supposed curvature. I made a slide of what we should see at this distance. So at the car park, 6.7 meters above sea level, 5.1 meters should be hidden according to the Earth's curvature and the curvature calculator. So this picture is what I observed, and this is what I should see when I subtract 5.1 meters, because I know that the lighthouse is 14 meters high, and it's standing practically at sea level. So you could say, okay, there's maybe not so much of a difference between these two pictures, but okay, we go further. So at 1.7 meter above sea level, 12.5 meters should be hidden. So to the left is what I actually observe, and to the right is what I should see. I should just see the very top of the lighthouse, almost none of the white, just a little red hat, and I should only see the chimney here and part of the top part of the house. But I actually see, here is the white part, so I see all of this white part. I see and I shouldn't here see the roof of the house, but I see the roof of the house, and I see the white wall of the house, and then it gets kind of blurry, so maybe you can't really say that you see anything below this point, but you see definitely more than you should see. Then 1 meter above sea level, 14.8 meters should be hidden. And remember that the lighthouse is 14 meters high. So this is what I should see. I shouldn't see the lighthouse at all. It should be below my horizon here. Shouldn't be possible to see. And I should only be able to see the very top of the chimney here, and this little thing with, I don't know what this is. But anyway, just the top of the chimney. And what my observations, I see almost the same as I saw 1.7 meters above sea level. In the previous picture, I see a lot of white here, which comes from the lighthouse. I see almost the same amount of the wall here. I even see the fence here, which I definitely shouldn't be able to see at all. I should even be able to see the fence here at the car park. So let alone 1 meter above sea level, I should not be able to see this. I should be able to see nothing really, because I shouldn't be able to see anything below the point of this arrow. Nothing below this line. That's according to the curvature. And in addition, if you look at this picture, for instance, if you take in consideration the atmospherical conditions, etc., it was a very, very windy day with a lot of water vapor above the sea, and as you see in the picture, they are pretty blurry. So even though it's only 17.3 kilometers away, so most likely if the curvature was as we have been told, I should probably not be able to see anything here, because I should only be able to see this very top based on the curvature, and the rest would probably in practice be hidden or blurred away by the atmospherical conditions and the water vapor above the sea level. So this is the third time I taking flat earth pictures, and I see no sign of curvature. I see that the atmospherical conditions makes my pictures blurry, but that's really all I see. I should see big differences between here, for instance between 6.7 and 1.7 meters. I should see big differences in what I should be able to see. And you can maybe say that you see a little bit less on the bottom here, for instance here, compared to this picture. But you see also that the top is very blurry, the bottom is equally blurry. It's not really more blurry than the top, so I would say this is no indication of curvature. This is more indication of atmospherical distortions. And here, when you're 1 meter above sea level and you see all this, and you should be able to see anything, then I would say not really any sign of curvature at all. So my conclusions after 3 observations is that I've still not observed any curvature. And you can see my other video on top here if you want. It is at twice the distance, where I look at the house across a lake, and I still see no curvature. And in the bottom right here, I have gone through the calculations behind the Earth curvature calculator to verify that they are correct.